Good morning, I'm Sylvain Brisse and I will present you the BIGSdb-Pasteur platform and especially its application to Klebsiella pneumoniae. So I'm working at Institut Pasteur in the unit Biodiversity and Epidemiology of Bacterial Pathogens, where we have a Klebsiella research group. And the reason why we are interested in the taxonomy of pathogenic strains is twofold. First, to detect and track the enemy, meaning the pathogenic strains, and second, to know better specific strains and having a way to recognize these strains can also stimulate research on them. I don't need to insist on the concept of multilocus sequence typing, which is behind the strain taxonomies that we are using in the BIGSdb-Pasteur platform. So regarding Klebsiella pneumoniae MLST, this all started in 2005 when we published the Diancourt et al. Paper with the scheme for 7-gene MLST of Klebsiella pneumoniae. And this was soon adopted quite widely by the community. In 2009, we showed that MLST allowed to distinguish pathogenic strains from non-pathogenic ones and was very important in terms of correlation with Klebsiella capsular types, which at that time were the main nomenclature of Klebsiella strains. And since then, the nomenclature of Klebsiella pneumoniae based on MLST has really become a universal nomenclature of Klebsiella strains, which you can find in many of the publication titles right now. As you can see from the bottom graph, the curation and the incorporation of novel sequence types into the database has been continuous since 2005. So regarding the taxonomy of Klebsiella, it's important to realize that the Klebsiella pneumoniae MLST scheme actually covers more than Klebsiella pneumoniae. It covers the entire Klebsiella pneumoniae complex, meaning Klebsiella pneumoniae and related species, including Varicola, for example, and also quasi-pneumoniae. So Klebsiella pneumoniae MLST curation is performed by a decentralized team of volunteers, which you can see here, and we currently receive more or less one curation request per day. So this is a very dynamic and active database. But on the other hand, the Klebsiella MLST platform is more than MLST itself. We indeed curate other nomenclatures, including the beta-lactamases of Klebsiella pneumoniae nomenclatures, like BLA-OXY, for example. We also curate, and this is done by the group of Kat Holt, the aerobactin MLST, salmochelin, colibactin, and the Yersinia bactin MLST systems. And currently we have more than 8,000 public isolates, 5,000 private isolates, and more than 500 distinct submitting laboratories that have submitted data to the database. So this MLST nomenclature has really been operational to recognize hypervirulent and multidrug resistant sublineages, which are now widely recognized in the field. And this is a slide from the group of Kat Holt, where you can see the dichotomy between hypervirulent strains, which have a lot of virulence genes, and multidrug resistant strains, or STs, if you like, which are loaded with a lot of multidrug with resistance genes, but don't have typically a lot of virulence genes. The trouble today is the emergence of so-called dual risk Klebsiella pneumoniae, which has been recognized also thanks to this MLST nomenclature. And also this nomenclature enables, at the global level, I would say, more complex ecological and One Health studies of Klebsiella, thanks to this universal language. So clearly today we are interested in going beyond MLST based on 7 genes, and this is a core genome MLST concept that we are also implementing in the Klebsiella MLST database. This consists of recognizing the phylogenetic structure of the species and then defining classification thresholds and using single linkage clustering algorithms to create classification systems. Currently, we are still finalizing a multi-level nomenclature system of Klebsiella pneumoniae, which you can see here. We are defining thresholds, the most appropriate thresholds based on the distribution of pairwise distances among the CG-MLST profiles. And this graph shows that the distribution is clearly not continuous, but you have discontinuities or no man's land, as I call it, in the distribution, where we intend to define the thresholds. And some thresholds will also be useful for species and subspecies definitions. So this is like the example of what it tells you in terms of classification compared to the sequence-based phylogenetic structure of Klebsiella pneumoniae. And you can see here, for example, a hierarchical system of classification and the correspondence with the 7-gene MLST system, which is quite good. And for this reason, and to avoid creating confusion, we are working on a so-called inheritance algorithm, where we will map the 7-gene MLST sequence type numbers onto the genomic core genome MLST nomenclature, so that the same widely recognized clonal groups are numbers are given to the groups that are known based on 7-gene MLST. So to share the genomic taxonomies, we will take advantage of features that Keys has developed called the classification schemes, which sit on top of the profiles or the schemes in BIGSdb and allow to classify strains based on single linkage clustering at any chosen level of allelic divergence. Finally, I would like to mention that the BIGSdb platform is not only Klebsiella. We have a number of pathogens that are covered on our platform, including, for example, Listeria monocytogenes, which is quite widely used, but also other pathogens that you can see here on this list. Finally, I would like to mention that developing genomic taxonomies of strains has a lot of implications in many fields, including population biology, computing biology, epidemiological surveillance and global health, and also ecology or One Health approaches, and sequencing and metagenomics. So this is a quite exciting field, and we need at this step to develop more interactions with other systems, platforms, and bioinformatic platforms in particular, and also to extend the functionalities of our nomenclatures, for example, towards metagenomics. Finally, I would like to thank the people who have contributed to this work, and in particular the team of curators in my group, in particular Virginie Passé. Melanie Henner is working as a PhD at the moment on the development of the genomic nomenclature. And you can see that we are also collaborating strongly with Keys and Martin on the implementation of novel features in BIGSdb when necessary. And also I would like really to make a special thank to the external Klebsiella pneumoniae database curators, in particular Radek Izdebski and the group of Cat Holt. Thank you very much for your attention.